Well, hello, statistics students. Welcome. Good to see you. Hey, today's notes are on something called hypothesis testing, and this is the final unit of the year. So let's just talk about what hypothesis testing is all about. So it says here, hypothesis testing is used to compare two groups statistically. So these are statistical tests that we can use if we want to do something like, let's say you want to compare the average GPA of males and females at Oregon High School. Or let's say you want to compare the percentage of Oregon students who are in sports to the percentage of students nationwide who are in sports. So whether you're comparing two groups like males and females, or you're comparing one group to a national percentage or an average, that's when we use hypothesis testing. So let's talk about how we would use this. So when we use hypothesis testing, there's 4 steps involved. And the first step is the toughest one. And it says state the hypotheses. Now, just something to point out. Hypothesis, or this word right here, is singular. Hypotheses is plural. And the reason it's plural is because we always have to state 2 things. Now, this first thing here, this HO or H sub O, is what's called the null hypothesis. It's what we believe before we collect any data. Like we might believe that the average GPA of males and females are the same. Or we might believe that our percentage of students who are in sports is the same as the national percentage. This other HA here, this other item, H sub A, is what's called the alternate hypothesis. It's also called the research hypothesis. And it's what we're trying to show when we collect our data. So there's 4 different ways you can set up these hypotheses. Let's go through each case. The first case looks like this. And you'd have an actual number in place of those symbols there, but you might say our null hypothesis is that the average is equal to a set number. Like for example, if you were trying to compare our GPA at Oregon to a national GPA, you might say the Oregon GPA is equal to whatever that national number is. Let's say it's 3.0. And you're trying to show that the average Oregon GPA is not equal to 3.0. So that's one way you can set up your hypotheses. Here's a second way. And you'd use this one if you're comparing 2 groups. There we go. So in this case, you might say the average GPA of females is equal to the average GPA of males. So that might be your null hypothesis. Your alternate hypothesis, what you're trying to show is that the average GPA of females does not equal the average GPA of males. Okay, so you're going to use one of those 2 choices if you're ever talking about averages. If you're talking about a percentage, here's what you might write down. So you might say, okay, let's compare the percentage of or the proportion of Oregon High School students who are in sports to the national proportion. So you might say something like the proportion of students at Oregon who are in sports is equal to, let's say, 0.75, 75%, whatever that national proportion is. And you're trying to show that the proportion is not equal to 0.75. All right, one last case, and it looks like this. This would be like if you're comparing 2 groups, like males and females. So like you might say, we assume before we start that the proportion of females in sports is equal to the proportion of males in sports. And we're trying to show that the proportion of females in sports is not equal to the proportion of males in sports. Okay, so your first step in hypothesis testing is to choose one of these, depending on the study you're looking at, depending on the data you're comparing. Now, the nice thing is, once you choose one of these, everything else you do follows from this. So this first step is critical. Okay, so once you do that first step, here's your second step. It says choose the appropriate test. So there's a 6th one down below, so there's 6 choices here. I'll see if I can squeeze that all in there. There we go. And these tests go in the same order as those hypotheses on the previous page. So if you are comparing the average of a sample to a set number, like let's say you are comparing the average GPA of students at Oregon High School to the national average. You'd use a z-test, or you'd use a t-test. So for both of these, you'd use one or the other when you're comparing the average of a sample to a number. Now, how do you know which one you're going to use? Well, the nice thing is it's very similar to the work we did in the last unit. If you have 30 or more data points, you're going to use a z-test. If you have less than 30, or if you don't know the standard deviation, you're going to use a t-test. Okay, so the key though is that these are for comparing the average of a sample, so like average GPA of students at OHS, to some number, like a national number. Now, if you're comparing two averages, like the average GPA of males and females, that's where you're going to use one of these. And again, these are both for comparing the averages of two samples. So you're going to use a two-sample z-test or a two-sample t-test when you're comparing the averages of males and females, let's say. All right, again, z if your samples have 30 or more, t if your samples have less than 30. Now, since you have two samples, let's say you have 30 or more males but only 20 females, basically if either of your samples has less than 30, you would use a t-test, okay? T is just a safer test. Okay, what if you're talking proportions? Well, this next item here, a one proportion z-test, that's if you're comparing the proportion of a sample to a number. And then below that, and I'll scroll down a little bit, is when you're comparing the proportions of two samples. Okay? Notice when we talk proportions or percentages, there's no z, there's no t. We just have a one proportion z-test. Now, the one proportion is if you're comparing like the proportion of students at OHS who are in sports to a national proportion. Two proportion z-test is if you're comparing the proportions of males and females who are in sports. Okay? Notice these 6 choices all follow from the hypotheses you set up. So whatever you set up for your hypotheses, you choose the test based on your hypotheses. Okay, third step. It says find and interpret P. Now here's the nice thing. We don't have to do any calculations for this. There are formulas for each of those, but we're not going to do those. Instead, we're going to let our calculator do all the work for us. So I'm just going to grab this quickly, and I'm just going to show you where this is at. You might want to write this down, but if you press your stat key and go over to tests, it's choices 1 through 6 in here. Okay, so you might want to make a note to yourself that you're going to press your stat key. From there, you'll go to tests. And it's going to be one of those first 6 choices. Now, take a look. Those 6 choices, I'm just going to scroll back here, are the exact same 6 choices here, in the same order. I did that on purpose to make it a little bit easier for us. So, depending on the test you chose, you're going to press Stat, go to Test, and pick one of these options. And we'll do a couple examples so I can show you what that means. Let me put my calculator aside for now. And let's just talk about what this p-value tells us. So a really simplified way of thinking what P is a probability that the null hypothesis is true. Okay. Now, actually, statistically, it's got a more complicated definition than that, but this is probably the easiest way of thinking about what P is. All right, last step. State your conclusion. And here's our 2 options. If that probability is very small, less than 0.05, and we choose 0.05 because we want to be 95% sure, kind of like we saw in our last unit. If P is less than 0.05, we reject the null hypothesis. Essentially, this is saying we have enough evidence to say that the null hypothesis is not true. Now, second thing says if P is greater than 0.05, do not reject the null hypothesis, meaning we might have some evidence, but we don't have enough evidence to reject this idea. Now, two things just to point out. First of all, notice I didn't say what if p equals 0.05. Well, different textbooks have different interpretations of that. So until I see a definitive answer, I'm just going to leave it like this. But second of all, to be honest with you, I have never, ever, ever in 20 years seen real data that had a p-value of exactly 0.05. All right, here's the bigger thing to address. Notice in one case we reject the null hypothesis. In the other case, we do not reject the null hypothesis. We never accept a hypothesis. We either reject the null hypothesis or do not reject it. It's kind of like if you went to court and you were to plead your case before the judge would either find you guilty or not guilty. They never really find you innocent. So if they have a bunch of evidence against you, they find you guilty. That's like this, reject the null hypothesis. If they have some evidence, but it's not strong enough evidence, it's like this, do not reject the null hypothesis. They find you not guilty. So keep in mind, you never ever accept a hypothesis. You either reject the null hypothesis or do not reject the null hypothesis. Okay, so that's your 4 steps. We're going to go through a couple examples, and before I put the examples up here, let me just warn you. They're wordy. These examples have a lot of text, so we need to really interpret the problem that we're reading. Okay, here's our first example. And don't write all this text, but let's do write the important stuff we need at the end. So this says a certain type of pain reliever states that it contains 325 milligrams of acetaminophen in each ounce of the drug. Ladies and gentlemen, this is a fancy way of saying Tylenol has 325 milligrams of active ingredients in each pill. Okay? Now, every company, including Tylenol, tests their products to see if this is true. So they take 70 1-ounce samples, so 70 pills, and test to see how much acetaminophen it has. And they find that the average is actually about 319 with a standard deviation of 25. Okay? So we want to test the claim that the sample mean is 325. So that last sentence says, test the claim that the sample mean is 325. See that word mean? That means we're not going to use those proportion tests. We're going to use one of the sample tests. Okay? We're going to use a Z or a T or a 2 sample Z or 2 sample T. And since we're not comparing 2 groups, this is either going to be a Z test or a T test. Okay? Well, I'm getting a little bit ahead of myself. We need to state our hypotheses first. So here's what we are testing. We're testing, is the average really 325? So our null hypothesis is going to be our average equals 325. Essentially, we set that up before we collect any data. So don't look at the 319 or anything else. The very first sentence says, we believe going in that the average is going to be 325. And what we're trying to show is that the average maybe does not equal 325. Okay. Step 2, choose the appropriate test. Well, since we have an average equal to a number, it's either a Z test or a T test. And since, I'll scroll back up here, we had 70 samples, we're going to use a Z test because we have more than 30 samples. Okay. Step 3, find the p-value. So I'm going to grab my calculator once again. Okay. And remember, we press our stat key, we go over to tests, and I'm going to choose that first choice, Z test. If you actually have all the numbers, you're going to highlight data, but if we have a summary of our numbers like we do here, we'll highlight stats. The first choice is our original mean, that's 325. Second choice, that's our symbol for standard deviation, that's right here, that's 26. X bar is our sample average, that's what we determined when we collected our data, that's 319. N is the number of samples we have, that's 70. Whoops. And for this unit, we're always going to highlight the not equals to sign. It is possible to have a greater or less than sign here, but we're never going to address that in this class. You might see that down the road if you take another stats class. Okay, and then I'll calculate, and it does all of our work for us. Now, it gives us a bunch of information. What we really need is that p-value. Okay, and the p-value it tells us is p is about equal to 0.054. Okay, remember our two possibilities. If p was greater than 0.05, we do one thing. If p is less than 0.05, we do the other. Since p is greater than 0.05, we do not reject h sub o. Here's what this means. It means we have some evidence to show that the average maybe isn't equal to 325. But based on this, it's not strong enough evidence. So based on the evidence we have, we can't reject that idea. Okay, I have one last example, and then we will put our notes aside. Okay, second and final example. A vote is to be taken to determine whether casino gambling should be legalized. This actually happened in the Madison area. A number of years ago, the Ho-Chunk, actually the Dae-Joke Casino in Dane County, they wanted to make it a full-fledged casino, and they put it up to a vote. And in the end, the voters said no, and so now it's classified as a bingo hall and not a casino. But anyways, I digress. Back to the problem. So we're taking this vote, and we want to know, is there a difference in the proportion of urban and rural voters who favor the proposal? So we ask a bunch of people who live in the city, urban voters, and a bunch of people who live in the country, rural voters. So here's what we find. 123 out of 210 urban voters said yes, we favor this. 244 out of 515 rural voters said yes, we favor this. Is there a difference in these proportions? Okay, so first step, state the hypothesis. So we're comparing the proportion of urban voters to the proportion of rural voters. So that's our null hypothesis. Our alternate hypothesis is that those proportions are not equal. So we initially think that yes, these proportions are the same. We're trying to show that they're not the same. Okay, everything follows from that. So once our hypotheses are set up, choose the appropriate test. Well, since we're comparing two different proportions, the percentage of urban, percentage of rural voters who favor this, we're going to use a two-proportion z-test. Okay, let's do our test. So from here on out, we can grab our calculator, press the stat key, go to tests. The two-proportion z-test looks like the sixth choice. And it asks for some x's and n's. Well, x1 would be 123 out of n1 would be 210. So we type in our first proportion, then our next proportion, 244 out of 515. We're going to scroll down to the word calculate. And we get a very small p-value, so our p-value is equal to about 0.006. Now remember, if this p is below 0.05, that's our cutoff. Since it is, here's our conclusion. Reject h sub o. So what that means is, we're rejecting this idea. We initially said, hey, we think these proportions of people will be the same. We have enough evidence to say that, in general, urban and rural voters have very different opinions on the legalization of casino gambling. Okay, so let me just summarize quickly. I'm just going to scroll back through. With hypothesis testing, first step, you're always going to state hypotheses just like this. Your null hypothesis and your alternate hypothesis. And it's always going to be one of these four options. Based on those four options, you're going to choose one of these six tests. Once you choose those tests, we're going to let our calculator do the work to find our p-value. And once we know our p-value, we're going to state our conclusion based on that value. Okay, ladies and gentlemen, every problem you're going to see is like these two examples where there's a lot of text. So dig through the text, see if you can make sense of it once you interpret it. The nice thing is the calculation part will be done for you using your graphing calculator. Okay, please, 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 if and when you have questions, check in with me. I'll be very, very willing to help you out. Good luck with all of this, and take care.